I hope you're having an amazing day. Welcome to another episode of 10 p.m. University. So today we're gonna talk about the second part of integration. So in the first episode, we talked about indefinite integration, right? And if you haven't watched my that episode, I will highly encourage you to watch that one before you jump into this one. So today we're gonna talk about definite integration. So definite integral of a function, right? Let's say we got a function here, fx. And we got a we got an interval, say a and b, right? And this is often denoted by so this is the range fx dx, and if you take the integration of it, so you will get something f of b minus f of a, where a and b are known as the lower and upper limits of integrals, right? Now it does not involve a constant of integration, and it gives us a definite value at the end of the calculation. So now you might wonder, what's the difference between a indefinite integration and definite integrals and indefinite integrals, right? So the primary difference, right, between definite and indefinite integral is that a definite integral, if it exists, right, is a real number value, whereas indefinite integrals represent an infinite number of functions that differs only by a constant, right? Sounds pretty straightforward. Okay, so let's do one example here, just to make it very clear. So we won't be doing much detail today because I wanted to give you concept, I wanted to give you tool set so that you can go and practice by yourself, right? Pretty straightforward. Okay, so today I want to make a session very shorter. So the first thing, let's do this example here, 2 for 1 by x dx, right? Okay, so now what we're gonna do, so when we solve this one, right, so forget about these two for a second, right? Just think about this one. So as we know that if you take the integration of 1 over x dx, right, we will get as log of x, right? Okay, now based on this one, right, so we get something like this, log of x 4 2, right? And this can be actually substituted to something like this. So that is log of 4 minus log of 2, right? Which can also be simplified as log of 4 by 2, right? Which equals to log of 2, right? Pretty straightforward, right? Nothing fancy. So this is how we simplify. So you start with an equation. You start with the function, right? So this is a function. So here, this is a function, right? And so don't worry about the limits, upper limits and lower limits for now. Forget about that one, right? And you do the integration of so this specific function, right? And you get this value, right? And using this equation here, using this indefinite integral method, so this can be split into log of 4 minus log of 2, right? And this will become something like this, right? Cool. Sounds interesting, right? Okay, sounds good. So what we're gonna do, let's clear this off, and then we're gonna do one more example, and then we jump into integration by substitution. Right, okay. This is just the clean part, which is the fun part. You know, my main intention of doing this maths week is just not to give you a complete replacement of what you learn in university, but just to give you a tool set, so that you can think about it and see whether you can use it in your daily life anywhere, or if you're someone who wanted to know what integration or differentiation is all about. So that's exactly my main intention, is to kickstart you with an interest, so that you can go and explore by yourself, right? And so that's why I named this university as a 10 p.m. University, so that before going to bed you learn something new, and when you wake up and realize, aha, I knew integration now a little bit I understand what integration is all about, right? So that's the whole idea behind the 10 p.m. University. We're going to talk about it at the end of this, and it's going to talk about my plans and all kind of stuff for 10 p.m. University. So I'm gonna talk about it at the end of this lecture today. All right, sorry I digress. So let's do one more example, right? So we're gonna do one more integration. So we're gonna do 6 square x dx Sorry, my apology for using trigonometry. So this will become, so integration of this one, right? So we'll, if you remember, it's tan of x, right? 0 pi by 4, and this could be equal to tan of pi by 4 minus tan of 0, right? So that's how you can work out. So this can be simplified, but just gonna keep it till here, right? So if you remember, so this is exactly what we did, right? So you take the when you deal with definite integrals, right? When you deal with a function like this, for now, forget about these two values, right? Limits, right? And just work out this one first. When you work out this one, you will get something like this, right? And then once you get the value, just put that into form of square brackets, and then put the limits, upper limits, right, onto the right hand side. That's lower and upper limit, and then work out. So that's that. Work out the equation. So that's pretty much you have to do in this case. Nothing much, nothing fancy. You can practice. There are a lot of examples out there. Explore more. So I've given you tools that now you know where you can do this stuff, right? It's very nice. It's a very simple way to do it, right? Cool. All right. So now what we're gonna do, let me clean this boy first. We're gonna do definite integral by substitution, which is similar to indefinite integrals by substitution, except that we don't have limits, right? Lower limits and upper limits. So in this case, we do have a limit, and we're gonna use that limit to solve our problem. Right, okay, so let me clear this one. Okay, so let's give a very simple example. Let's do one example here. Right, so let's start with this one, right? It's not simple, but you know what I'm talking about. X squared plus 1 dx, right? Okay, now if you remember by substitution, right, we take a value and we take a function, right, something like this. So we have x to the power something, right? So x to the power dx, and then we take this and substitute with t, and then you do the differentiation and then replace the dx with dt, and this with t dt, then something like that, right? So what we're gonna do in this case, we're gonna take this boy off, x squared plus 1, that's this denominator, so this the bottom one, and then we gonna put that as equals to t, right? And we're gonna do differentiation of it, and then you're gonna get something like 2x, right, dx equals to dt, right? Pretty straightforward. And that means x dx equals to dt by 2. Now you might wonder why I've done this one, right? So look at x dx in your actual formula, right? So sorry, actual function. So x dx, we got the value of x dx here, right? dt by 2. So how do you write this one? 2. This one is t, right? And we got dt by 2. So this equals to 1 by 2. And dt by t, right? Does it ring the bell, right? 2, 4. So what we done? So we replaced x squared plus 1 by 2, which is 3. Now we're gonna do integration with respect to dt, with respect to t. So what we're gonna do, we're gonna do integration on this one, so which will be equals to log of, right, log of t. Does it make sense? Log of t, right? 1 by 2, right? So this will be right. So there's one. Now you might wonder, I'm doing something like this, right? But there is a problem here. Now you might wonder, what's the problem here, right? So the problem here is, remember this one, we are actually doing a substitution here. So we have until here, so there is the actual problem starts from here, right? Okay, so what happens is that we have substituted this, we have substituted this, we have substituted this, everything we change it to t. But what about this ones? These are still the corresponding values associated with x. We need to change that to t, right? So when x equals to 2, then t equals to 5. Now you wonder how? Because t equal to x squared plus 1. Substitute the value of x here, right? And this will become 5. And now when x equals to 4, now this is a 4, so that will become 17, right? So the equation changes the dynamics altogether, so it will become 5 to 17 log of t 1 by 2, which can be written as half log of 17 minus log of 5 equals to half log of 17 by 5. Does it make sense? Okay, let's recap what we've done, right? Let's take an equation and let's do it, right? Okay, I will become more simple here. I know that this is a bit tricky, but you'll understand what I'm trying to do. Let me clear this one, right? And then we will explain what I'm trying to do. It's very nice and easy if you understand the concept, right? So okay. All right, so let's do this okay, so let me select the pen here. Okay, so let's do this very equation here. Excuse me. Okay, so we do what? 2, the same one. 4, okay. X squared plus 1, right? Dx, right? Very simple. We're not going to do any, denominator, nothing. We're going to stick to a very simple function here. So use the law of substitution. T equals to x squared plus 1, right? And now, so we're going to have x dx equals to dt by 2. Is that correct, right? So what will be x dx equals to dt by hang on, that's no, that doesn't work because we are still gonna have a problem here. Right, that's right. Okay, all right, leave it for now. Sorry about that. I take it back. So that equation actually doesn't fit because we can't use this one here. Sorry, because we still have this x dx problem here. So what we're gonna do, do x plus 1, right? This is better. Okay, and now we're gonna use the pen here. Right, okay. Right, so this sounds good, right? Right, so this is a very simple equation, right? So x plus 1 dx, right? Substitution law. Okay, so what happens is, now in this case we use the differentiation, so this will become for now we're not gonna talk about the limits here. So this will become x plus 1 will become t, and this will become dt, right? So now what about the ranges, right? Now you may wonder. So we have to work out. So now so this 2 and 4 are associated with value of x. Now we are not using x, we are using t. So we have to work out t. So Substitute 2 here. 2 plus 1, 3. 4. 4 plus 1, 5. Okay? So this is what we got. Now, what's the value of this one? It's pretty straightforward, right? T1 plus 1 by 2, right? And then we have 3, 5, right? So this will become T squared plus 2, 5, and 3. So now what we're gonna do, so we gonna put this value here, so that is equals to 20. So we're gonna do 25 by 2 minus 9 by 2, right? So that's equals to 25 minus 9 by 2, right? So this is how you solve the stuff here. So what we did, it's pretty straightforward. So we started with this equation, right? And it's a bit different to definite integrals here, because indefinite integrals where we are actually putting the, see, we are actually working out this here, right? So we are substituting this with this, which is pretty straightforward. And then we do the differentiation of it. And after that we do a differentiation. So we are actually not replacing this back, right? If you remember, in terms of when we did a definite integrals, right? If you remember, we were actually putting the value of the t back to to x plus 1. But in this case, we are actually replacing the limits with the value of the t, right? So we have this 2 and 4, which is associated with x. Now, so after we substitute this, we work out the value of t, that's a lower limit and upper limit based on the lower limit of x and the upper limit of x. So in this case, we worked out 3 and 5. So because the value of x equals to 2, so it will become 2 plus 1, that is 3. And then we have the value of x equals to 4, that's the 4 plus 1, that's become 5, right? So now this is the integration of t dt, which is pretty straightforward. And now what are you going to do with the integration of t dt, right? The integration of t dt will become t squared by 2. That's exactly the formula of x to the power n, right? So which will become x to the power n plus 1 divided by n plus 1, right? This is all about it is. There's nothing fancy here. So after that, you replace this 1, 5, and then you replace this with 3, right? So this pretty much will cover the equation for you. I know that integration can be a bit challenging, but please practice more. You will get to know more stuff about it. If you are someone who wanted to be aspiring machine learning engineer or deep learning, so you will need to know a calculus a bit, like integration, differentiation, matrices, right? So that's why I covered matrices, then differentiation and integration, just to give you a bit of head start about the different rules we use, right? So that when you are actually looking at a research paper, right, it's difficult to read a research paper. I have never written a research paper, right, because I'm not a computer scientist, so I have never written a research paper, but I have been fortunate to read a research paper. I read many research paper. It is tricky to read a research paper. I tell you about that. It's not easy at times, right? When you have a lot of complex equations, right? You need to figure out sometimes if you don't understand calculus very well, and if they've used calculus in the research paper, it will be a bit challenged, right? If that's the area, something you're looking forward to invest your energy and time in. So if this is something you're interested, I would highly encourage you to go and practice more, read about it, and especially read about the practical usage of all this kind of stuff, right? Because my main interest is to give you tool set, and I given you tool set. I talked about indefinite integration, definite integration when we talked about differentiation, product rule, chain rule, quotient rule, right? Different stuff. And I expect you to go and investigate more if you are interested. If not, it's fine. I mean, you can forget about it, right? There are many things which we not interested, right? So coming back to my channel, right, 10 p.m. University. I'm not sure if you've read the story why I've started this, but to make it short, to keep everything simple and short. So the reason why I started this so that, you know, I started getting a lot of information before I go to bed, right? At 10 p.m. So I go to bed at 11, and then every day I wake up, I have some sort of new information, right? And which has actually helped me directly or indirectly in one way or another in my life, right? Over a course of a few years. And now I wanted to share the same knowledge with you guys, right? You know, so that we can make an informed choices about certain things, right? Because sometimes we make choices in life based on whatever we know. And whatever we know at times is very, very limited because there's a lot of information out there. And there are certain things only we can remember, right? Even if you learn every single day for an hour, it's still whatever you can learn is limited, right? So my main interest of this channel is the 10 p.m. University, which eventually I'm going to make it LLC. So just to impart to you everyday knowledge about different things, you know, about different topics, you know, so that you can have a general opinion about different stuff around the world, like from a music, from an art, from a history, you know, from mathematics, from health, from fitness, from drinking beers, right, and from eating different kinds of food, something which affects us in a day-to-day life, right? That's all about my main intention, to help everyone out there. That's all about it. So that's the plan I have. If you wanted to have, you know, give me more ideas, I'm very happy to look into that, right? So that's exactly why I've started, right? Because we're going through this pandemic, right? And I was wondering, imagine if you're going to have another one in 10 years' time, it will be a biggest, worst game changer in the history of our planet, right? Because, so you got to know yourself, what you're getting into, you need to understand, you got to train yourself, you know, you need to you know, train yourself with information, right? Information is power in today's time, right? So that's all I wanted to say, right? Cool. So I hope you find today's session useful. And my apologies if you find it a bit complicated, and my apologies for that, you know, gibberish stuff, you know, at times this tool does, right? So that being said, greetings and adios from New Zealand. Take care.